Hello students, today we'll be following up what we have learned before that with regards to interaction through application of force. So for this we will learn what is gravity. So gravity is the force that actually pulls all object towards the earth. So what will happen is, let's say this is a picture of earth. And what we'll see is that gravity is this force that will try to pull all of you towards the center of the earth. Okay, in all direction. So this will all happen is, as a person, right, you will always be standing on earth. You will not float and anything. And this gravity usually exists between two objects with mass. Will be this it is important that you need to know what is the difference between mass and weight, where later on we'll be talking more about it. And gravity is an example of a non-contact force. Non-contact force, that means there is no physical form of contact with each other, and yet there is still some effects of what the force can do. So for gravity of the moon also exerts a gravitational force because the moon contains mass. However, due to its smaller size, meaning it has lesser mass, right? The force of gravity is only about 1/6 of the force of gravity of the Earth. Meaning, right, in terms of pulling towards the middle of moon, it is 1/6. So how will it affect you eventually is it will actually affect your weight, where you will actually feel lighter on moon rather than on earth. The moon's gravitational pull on the water in the oceans is also causing the difference in tide change, where the nearer the moon is to the earth, it has a greater gravitational force pulling the water upwards, causing high tide. Now, weight, on the other hand, is a measure of the force of gravity exerted on an object. A very common misconception or something that a lot of students tend to think it wrongly is that weight is in kg. Wrong. The SI unit for weight is actually in newtons, and this usually comes out in exam as a trick question. Okay, the weight for the SI unit for Newton, right, is a capital N, and this is a force. How do you calculate weight? Weight is generally equals to the amount of mass times the gravity. So the gravity, if let's say on Earth, is always 10, then whatever mass you have in kg have to multiply by 10 to give you the weight in Newton. This one, please go and memorize. This is very, very important, especially for exam. In that, what is the difference between the mass and the weight? Mass is a measure of the amount of matter in an object, and that the SI unit of mass is kilogram. So what we can see is mass definition is actually just in kg, and on top of that is the amount of matter on an object. However, when we look at weight is generally the weight is generally different in a sense where weight is actually the amount of gravitational force acting on the mass, and the SI unit for weight is actually in Newton. And because these two are using two different kinds of items, there are ways to actually measure it differently. So if we were to take a look at the table of differences, okay, this is what we will need to take note of. Where we can see that the difference between the weight and the mass. So what I would need y'all to do is really to remember the general difference between these two, like what is the mass, how to define mass, and how to define weight. Sorry, let me try to find. Okay, never mind. Okay, so in other words, right, a difference between mass and weight. So you have your mass and your weight. So you could see that for mass, right, it's basically a measurement of amount of matter. Okay, while weight is the gravitational force acting on it, on the object. The other difference is that for mass, it is actually the SI units in kg, whereas weight is in Newton. And lastly, for the mass, what will happen is it will remain unchanged at any location. For the weight, it will change or varies due to the difference in location. Last but not least, how do you go about measuring mass and weight? Okay, for weight, you can use a beam balance. Sorry, sorry. The mass, you can use a beam balance, or then for weight, it's mainly use a spring balance. Because in our previous lesson, we learned that for weight, as is an example of a force, you are able to use, and to measure force, you are able to use spring balance like this to measure force. Okay? Next, we look at what is pressure. So pressure is mainly the measure amount of the amount of force acting on a unit, and this is the pressure. It can be represented by a formula. Pressure equals to force over area, where force is in Newton, area is in meter square, and pressure is in Pascal, PA, okay, capital P. And what we can see is that having a larger base area, right, you would actually be able to distribute the amount of force acting on the area. So when you have actually, like, let's say a pin that has a very small area of contact like this is the small area of contact here, it is easily able to have apply better pressure to push it down. On the other hand, if you have a flat surface like this, which has a larger surface area, if you were to push it down, it would not get pushed down. It cannot unless you apply greater amount of force. So pressure really depends on the force and area, where pressure can be represented through this formula. So what happens is, if, let's say, the surface area is high, when your force remains unchanged, this will result in a in a smaller value, therefore pressure would actually be smaller. You can actually use numbers to represent this. Let's say you have 10 Newton over 100 meter square. You will get maybe 0.1 Pascal for pressure. However, if you remain the pressure, the force to be the same, divide by a larger area, okay, let's say 1000 meters square, you get 0.01 Pascal, which is a smaller number. And of course, the opposite is true, in that if, let's say, you use a smaller area, your pressure would increase, okay, like this. Now, in the event that you use pressure, pressure, but you change your force, and what will happen is your force, if your area remains unchanged, your force increases, your pressure would also increase. This is because the top number actually grows bigger. And the same thing will actually happen if you decrease it. If you decrease force, you will decrease pressure. So how do we actually increase or reduce pressure in our daily life? You can actually use, like, when you cut, right, you use a very blunt object, and this blunt object, you will not actually be able to cut things. However, if you use a very sharp object, you will be able to cut things easily. Second thing is the studs on the football has very small surface. So all this has very small surface. And this small surface will then be able to actually hold and ground will actually be able to get stuck or push it through the grass field, and therefore what will happen, you have a better grip in terms of running. The other one is, like, let's say you want to walk through snow, where snow is very easily able to sink in. So what happens is, you could see that the surface area for the boots is actually a lot larger to distribute your weight, which is the force. And this allows you to have lesser pressure and therefore not able to sink. So in your answer, if you are required to actually explain this kind of answer for exam, always explain it in the form of what happens to your surface area. And what happens about the force? Is it unchanged, or does it increase or decrease? This will then lead to your pressure. Does it increase or decrease? And therefore, the effect. Do you sink down, or do you stay afloat? Okay, so this is how you should write your answer in terms of explaining. Like what we shared, how do we calculate pressure? Pressure can be calculated using this formula, force over area, where the pressure is in Newton per meter square, or it can be in Pascal. Okay, area will be in meter square, force will be in Newton. Okay, this is an example of how you can go about calculating. This one is quite straightforward. You can pause the video to try this again, this question. Okay, so what actually happens is, in order to calculate pressure exerted onto the ground, you can take 40,000 over 0.1 meter. This would be the pressure. So if you take 40,000 divide by 0.1, you get 400,000 Pascal. Okay, then of course the rest you can more or less calculate it. So let's say for female, the shoe is 450 divided by 0.0001, 450 divided by 0.0001, you get 4,500,000. Of course, Which one will exert a greater force? It will be mainly the elephant, because they say force, right? But greater pressure, it will be the lady shoe. Leave a hole is due to the um, is mainly for the one that has a higher pressure, so the one is the lady. Okay, pressure in liquids and gas, they also do change along the way. What will happen is the water pressure when you go right deep underground, right, it actually will come crushing on you due to the amount of mass and weight of the water around you. So the metal must be able to withstand the high water pressure, and the air around us will be actually pressing on us in all directions. And this is known as air pressure. So what will happen is due to this difference in air pressure, it helps us to like suck water in or drink. It can also use a suction cup to be stuck onto the wall, where what will happen is we are actually removing the amount of air here. Air comes out, and this will actually result in it having a difference in pressure due to the vacuum in this area inside here. Therefore, pressure amount of air will try to push it in. So a change in air pressure can result in breathing difficulty. That's why if the airplane flies at very high altitude, okay, where the air pressure is tentatively low, oxygen or air has to be, I would say air has to be pushed in, pumped into the aircraft to maintain the air pressure so that you're able to breathe normally. As compared to, let's say you go hiking or climbing a high mountain, sometimes the higher you go, the air is thinner, so it gets harder to breathe. Now, um, sometimes forces can also be very destructive. Okay, and these are some of the destructive forces of nature. So you have the earthquake. The earth crust will consist of large plates that are continuously moving, and when the plate meets, they push against each other with great force. This will then cause this force being released will cause the plates to move suddenly, and each of it, when the two plates are actually hitting each other, they will actually cause friction, some form of friction or earthquake. And this will actually result in energy release during an earthquake that can cause damages. Tsunami is where you have very high, very large water waves generated from the powerful earthquakes. So what will happen is you will actually be submerged, and it can actually the amount of force generated from these waves can be very high, so they can actually crush it onto you and destroy buildings. Volcano is another one whereby below the Earth's surface is this hot liquid called the magma that will tend to pull out some form of force exerted on the crust, leading it to explode upwards if the pressure is too great. Then, when it reaches the surface, it will then be cooled down to form lava, and this can cause a lot of damage as well. Finally, a typhoon is actually a very powerful storm with strong winds and heavy rains. So these winds, right, can actually exert to a speed of 200 km per hour, and that's where you can actually cause a lot of floods or even damage to properties. So that is all for this chapter. We have learned that what is a force, how to go about measuring it, what are the effects of the force, and there are different types of forces. There are two main types, contact and non-contact force. Okay, some examples of contact force are like a friction. Okay, your non-contact force can be your magnetic force, gravitational force, or even electricity. What are some of the things that can be calculated based on the effects of the force? Your speed, and examples of force that can generate destructive E is this one. Force, there's also frictional force. You have learned the advantages and the negative effects of friction and how to overcome friction. You have also learned of the difference between mass and weight, which is important for exam. Finally, we have talked about pressure, where pressure, how to go and calculate it, force over area, what's the SI unit, as well as how pressure can actually be changed in a liquid and gas environment. Okay, and that is all for this chapter. Okay, so for the remaining time, do review the slides, and that's all for today. Thank you.